Hey guys, Mr. Gucci here, and this short video is going to discuss with you how to tell if a double replacement reaction occurs based on the products. So I'm starting off actually where my last video ended. I completed the double replacement reactions for the first three problems on your homework. 1, 2, and 3. This is actually problem 4, 5, and 6. Now what I'm going to go and do is I'm going to go through each of these problems to determine whether or not a chemical reaction even occurs. And the way you do this is figuring out if one of the products, just one of the products, needs to be insoluble in water. So we are going to look these products up and we are going to see whether or not they are soluble in water, meaning they dissolve, or insoluble, meaning they do not dissolve. The reaction only occurs if one of the products is insoluble in water. So let's take a look. We're going to pull up the solubility table. The first thing we're going to look at is zinc hydroxide. So the way this solubility table works is you have got positive ions on the left-hand side and negative ions across the top. So let's look up zinc, which is right here, and hydroxide. So zinc hydroxide, take a look. Zinc hydroxide forms a solid. It is not soluble in water. So this means that the reaction will occur. So what I'm going to do is I'm going to just write in a little S and put it in after the zinc hydroxide to indicate that there is a reaction. All right, I'm going to write reaction occurs. And I'm going to, underline it. Great. Now, all we need is one of our products to be a solid, liquid, or gas in order for the reaction to occur. But just to be sure, let's double check this other one. Sodium iodide. Sodium iodide. So I'm going to go to the solubility table that's attached to your homework. I'm going to look up sodium iodide. Sodium iodide, we see right here that sodium iodide does dissolve in water. So I would just write here, let's change my colors for fun here. Sodium iodide does dissolve in water. So sodium iodide would not cause a reaction to occur, but that doesn't really matter here because the zinc hydroxide, the other reactant, the other product, does cause a reaction. So you only need one of your products to cause the reaction. All you need is for one of your products to be a solid, a liquid, or a gas. All right, let's take a look at the next one. Okay, so in this case, what we produce is lead-2 iodide and lithium nitrate. In order for this reaction to occur, one of the products, just one, you just need one, possibly two, that would be great too, but you just need one to be a solid, a liquid, or a gas. So let's take a look at this one first. Let's do lithium nitrate. Lithium nitrate. Let's look up lithium nitrate on the solubility table. Lithium and nitrate. Lithium and nitrate. Okay? Lithium nitrate is aqueous. All right? It dissolves in water. So lithium nitrate will not cause a chemical reaction to occur. Okay? Lithium nitrate will not cause this chemical reaction to occur. Let's check the lead iodide, however. Remember, we just need one of these products to be a solid, liquid, or gas in order for this reaction to occur. So let's take a look at lead-2 iodide. So we go to the solubility table. Lead-2 iodide. Take a look. Lead-2 iodide does form a solid. It is not soluble in water. And so I would write here a little S for solid. So this reaction occurs. This reaction happens. All right. Again, it doesn't matter that lithium nitrate does not form a solid, that it stays dissolved in water. You just need for one of your products to form a solid, precipitate, or a liquid, or a gas. Okay? Let's take a look at the next one. Now here your two products are H2O, which in this case actually is the result of, you probably wrote it down as HOH. All right, so hydrogen hydroxide, HOH, and NaCl. So we need to see, in order for this reaction to occur, one of these substances has to be a solid, a liquid, or a gas. Let's look at NaCl first, sodium chloride. So I go to the solubility table, all right? And let's see, that's better. Sodium chloride, sodium and chloride. So we see sodium chloride is aqueous, all right? It will not form a solid, liquid, or gas. So this will not cause the reaction to go forward. But that's okay. We get one more shot. Let's take a look if HOH is a solid, liquid, or gas. So we go to the solubility table. We go to hydrogen, hydroxide. And hey, it's a liquid. All right, it is in fact a liquid. We'll put it in another color. All right. All right. In fact, it's a liquid you're familiar with because HOH is actually H2O. If an ionic compound reaction, a double replacement reaction, produces water, then this is a reaction that will occur. Okay? So this reaction also occurs because we produce a liquid. Reaction occurs. Fantastic. Because again, all you need is for one of your products to form a solid or a liquid or a gas. Now, so far, everything I've been showing you is a reaction that has occurred. Let's take a look at a problem from the note, so that may not be the case. All right, so AlBr3 plus KCl yields AlCl3 plus KBr. Let me write that right down here. Okay. AlBr3 plus KCl yields AlCl3 plus KBr. And of course, you got to balance it. So let's see, 3 here, 3 here, put a 3 there, you're balanced. Okay, now, again, in order for this reaction to occur, just one of your products needs to be insoluble in water. So the first thing I'll do is I'll look up aluminum chloride. So I'm going to go to the solubility table, and I'm going to look up aluminum and chloride, and right here we see that this is soluble in water. So aluminum chloride is aqueous, okay? It dissolves in water. So this is not going to be something that causes the reaction to go forward, okay? So that doesn't cause a reaction. How about potassium bromide, KBr? Let's take that up. Let's look. Potassium bromide. Potassium bromide is also aqueous. So neither of these products results in a substance that is insoluble in water. So in this case, we would just write no reaction. Why? Because there's no precipitate formed, no solid formed, all right? No liquid or gas either, all right? Or another way you can say it is you can say all products soluble. Okay, so all the products are soluble. This, by the way, is the full credit answer to this problem. If I were to ask you, aluminum bromide and potassium chloride are combined together, what do you get? The correct answer is not some nice balanced equation. We get AlCl3 and 3 KBRs. That would get you half credit. In fact, it's possible to shortcut all of the crisscrossing and balancing you would have to do. Right? Like if I just gave you AlBr3 plus KCl, and I asked you to solve this problem, well, you would identify the charges. Aluminum is 3 plus, bromine is 1 minus, potassium is 1 plus, chloride is 1 minus. And you're like, okay, I'm going to combine the potassium and the bromide. But before you even do it, you can go to your solubility table and look up, okay, potassium and bromide, this doesn't give us a reaction. All right, and then you can look up, do the other one. Okay, well, in that case, I'll put aluminum with chloride. But before you go any farther, you can look it up. Aluminum and chloride, aluminum chloride is also, just a second, a soluble compound, okay? And so as a result here, you could just write no reaction. That's it. That's all you do. You don't even need to do the crisscrossing. You don't even need to balance. This is enough to get you full credit. Okay? All right, guys, I hope this video helped, and email me with any questions. All right, later.